Then we just subtract each part by pi. Then we get negative pi less than or equal to 2x and less than or equal to pi. Then we divide each part by 2. Then we get negative half pi less than or equal to x and less than or equal to half pi. So now the fundamental cycle is this open, okay, this closed interval from the negative half pi to half pi. Okay, now let's begin to draw the one cycle of this original function. We begin with the y equal to cosine of 2x. Okay, so we begin with this function, and then we do a series of the transformations to get the graph of this given function. Now, step 1, sketch one cycle of the y equal to 2x. So let's first draw the rectangular plane. And let's get the graph of the y equal to cosine of 2x. So on the 0 to pi. So we know the graph like this. Okay, so this is the graph of the y equal to cosine of 2x. And this is from the 0 to pi. This is the fundamental cycle of this cosine of 2x. Right. Now, step 2, we need to stretch this cycle vertically so that it has the amplitude of 2. And then we get the graph of the y equal to 2 times cosine of 2x. Because we need to, let me change this coefficient. Actually, I plan to draw the graph of the function with the coefficient equal to 2. Let me change this 3 to 2. Okay, it does not matter which coefficient to use, so let me just use the coefficient 2. Okay, so right now let's stretch this the graph of this function by a factor of 3 or by a factor of 2. So now this is the 1, this is the 2. Then you stretch the graph of this y equal to cosine of 2x. Then you get a graph like this. Okay, first let's mark out all those key points. This guy here, and this guy here. And then this is negative 1, negative 2, so here. And then this guy here. And then this guy here. So now we stretch this graph of the y equal to cosine of 2x to get the graph of the y equal to 2 times cosine of 2x. Okay. Then we get a graph like this. Okay, so this is graph of the y equal to 2 times cosine of 2x. Why I don't use the 3? 3 is too much, right? If I use the 3, my screen cannot hold it. Okay, this is the step 2. We just stretch this circle vertically so that the amplitude is equal to 2, right? So change from 1 to 2. Now let's look at the step 3. Step 3, we need to reflect the graph of y equal to 2 times cosine of 2x in the axis, in the x-axis, to get the y equal to negative 2 times cosine of 2x. So this is step 3. Now let's go back to the whiteboard. So we need to reflect this right curve about the x-axis. So that means this point goes to this point, right? And this point goes to this point. And this point goes to this point. Then we get a curve like this. Okay, so this blue one is the graph of the function y equal to negative 2 times cosine of 2x. Okay, so this is step 3. Now let's look at the step 4. Translate the cycle half pi units to the left. Let's go back to the original function, and you look at this original function. Okay, so you see this phase shift is equal to negative pi over 2. So that means we need to do the shifting to the left by pi over 2 units, right? So now let's go to the rectangular plane. So we need to shift this graph to the left by half pi. So this is the pi, right? So this is half pi. We need to shift this blue curve to the left by half pi units. Let's first shift those 5 key points. Okay, so this half pi, so that means this point just move to this point, right? Let me use another color. Let me use a brown. So right now, get this point here, and then this is the pi over 4. So this point shifted to here, and then the sky shift to here, and then the sky from pi to half pi. This point shift to here, and then this guy from here to here, right? So right now we get the graph of the such function. So actually some part just coincide. So right now this brown one, this is the graph of the function y equal to negative 2 times cosine of the 2 times x minus negative half pi. Then the last step, do the vertical translation. We need to translate the cycle 1 unit upward.